Welcome to another video. In this Quartic problem, we want to solve for all the x and the term of x raised to power 3 is not given and x raised to power 2. But to every problem, there is always a solution. Let's see how to solve this. If we are given x raised to power of 4 and I will do little manipulations by adding 2x raised to power of 2 plus 1 and I will still subtract it. Okay, so I added it to this x raised to power 4 and I'm going to write plus 4x and I will still subtract 2x squared minus 1 from it. So by doing that, so we are still coming back to the first given problem. So that is this and this, so they are going to eliminate each other, so I just manipulate it and everything equals to 0. Then so the first three terms here, it can be written as x squared plus 1 and all raised to power of 2. That is, if we try to expand this, we got what we have above plus as well. So why for this one, we have it as 4x minus 2x raised to power of 2 and here is negative 2. Everything equals to 0. Then for this one, we are going to have x squared plus 1 all raised to power of 2 plus, let's say I take out 2, then we are going to have, so this one remain, it's going to remain 2x and this one is negative x squared minus 1 all equals to 0. From the second bracket here, so I want to change the position of x squared, as in I want it to start then by taking out the negative values. Then we have x squared plus 1 all raised to power of 2 plus, then taking out the negative and change the position, we have negative 2 bracket, so this becomes x raised to power of 2 and the 2x that is coming to the middle change to negative because I've taken out the negative. Then here becomes plus 1. Everything equals to 0. Then we are going to have plus multiply minus, then it becomes negative. Then for this we have x squared plus 1 all raised to power of 2 minus 2 bracket, so this becomes x minus 1 all raised to power of 2. Everything equals to 0. If you try to expand this as well, you'll get what you have above. And this, what I want to do here is I want to apply this identity, the difference of the 2 square, but that equation doesn't completely give the difference of a 2 square. So here's the formula for it: a minus b bracket a plus b. So this is how to use difference of a 2 square. But because of these two, this doesn't complete, so we need to introduce the root and we take the square of everything. Here we have x squared plus 1 all squared. While for this one, as 2, we have negative, then we introduce the root to it, root 2, and we create a bracket as x minus 1. Then everything will be working under a bracket with square equals to 0. So by applying the law of indices here, so root 2 will take square and x minus 1 will also take square, so we get what we have above. So this look completely the difference of a 2 square now. Then we have x squared plus 1 by applying the negative first. So we are going to have negative bracket root 2 bracket x minus 1 all bracket, and we bracket everything. And for the second one, we have root bracket of x raised to power of 2 plus 1. Then we are going for positive this time around. We have plus root 2 bracket x minus 1 all bracket and everything equals to 0. So the first bracket will be equal to 0 and the second will also be equivalent to 0. But let's expand this thing first. Here becomes x squared. Though if we expand this root 2 with x, we are going to have minus root 2x. Why this one? We are going to have minus root 2 multiplied by minus 1, that is plus 1, right? Then plus this one, we have 1 plus root 2, and we bracket this. We create another bracket again for the second bracket. So here becomes x squared plus, so multiplying root 2 with x, we have root 2x. And for the second one, we are going to have 1 minus root 2, everything equals to 0. So here we come. And what we are going to do next is we equivalent these two brackets to the individual 0. So why for this one we have x squared minus root 2x, then plus plus the second one, that is 1 plus root 2. Everything will be equivalent to 0, and for the second one also will be equivalent to 0. All right, but I will leave that one. So I want to deal with this one first. This is more of a quadratic expressions, which is given as ax squared plus bx plus c. Let's change it to equation by equivalences to 0. So here is quadratic equation. So where ax squared is just x squared and other terms, so c is 1 plus root 2. Why the coefficient of x squared is 1, then by applying the general formula, which is minus b plus or minus the root of b square minus 4ac divided by 2a. We know our b as minus root 2 and a is 1, c is 1 plus root 2. So let's plug in everything in this. We have minus root 2 plus or minus the root of yb is still root 2 all raised to power of 2, and minus we have 4, ya is dot 1. Yeah, a is the coefficient of x squared, that is 1, dot y the bracket, we are going to have 1 plus root 2, and we divide everything by 2a, and the value of a is 1. So we start expanding this, then we are going to have minus root 2 plus or minus the root of, so root we cancel square, then we have 2. By expanding this with negative, we have minus 4 root 2, everything divided by 2. And the next thing here is we keep expanding as minus root 2 plus or minus the root of minus 2, and this we are going to have minus 2, that is 2 minus 4, that is minus 2 minus. So here is minus root 2 with 4 as the coefficient, then we have this as 2. Okay, at this stage I want to let negative out, so we'll be working under a root, and everything here later becomes the root of 2 plus 4. We have 4 root 2 multiplied by, so we are going to have root of minus 1. Okay, and everything divided by 2. Then the root of negative 1 is I. Then we will conclude that we have root 2, negative root 2 plus or minus the root of 2 plus 4 root 2 I, and all divided by 2. So and this one is more of x1 and x2. If you use this same approach, you are going to get the x3 and x4 by applying the second one. And this is how to solve this kind of quartic equation. I hope you learned something today. uh, Thanks for watching. So don't forget the steps I used. Subscribe to the channel, and I will see you in the next class. Never stop learning.